If we want to graph this ellipse here, okay, this is x squared plus y squared form, so this is an ellipse. It's hard to tell what the expansion and compression is until we make it equal to 1. So that's the first thing I'm going to do. I'm going to divide both sides by 36. And I'm going to generate x squared. When I simplify that, it's going to be over 9 plus y squared. 9 over 36 reduces to 1 over 4 equals 1. This then allows me to see my a value, my x-axis radius, and my b value much easier. Okay, and then once I have that, it makes it very easy to draw the graph. So I'm going to go 1, 2 along my y, 1, 2 along my y. I'm going to go 3 along my x-axis. Okay, so then I end up with my vertices, and again I can just sketch my graph in. So really what I need to do is make sure that I can identify my a squared and my b squared values. Okay, and once I have the vertices, I can sketch in my ellipse. Okay, all right, so how do we do this with hyperbolas? So going from a rectangular hyperbola to a non-rectangular hyperbola is really the same thing. The idea is that I've expanded along the x-axis by 3, along the y-axis by 2. And again, as long as I identify my transaxis, I know how to draw my graph. Now what's going to happen is, if I have a hyperbola with x and y, my asymptotes like that, if I compress vertically, I change the slope. Okay, if I compress horizontally, I change the slope. Essentially, my compression and expansion are gonna find the slopes of my asymptotes. So let's work this out. This is a trans x, so that's important. So let's go make sure we write that down. Trans x. Okay, this is very important. We know that it's along this axis here. Okay, maybe I'll just highlight that to make sure. We need to make sure vertices are along that axis. My a value is equal to 3. Whoops, this is going to be 9 squared, so the a is actually 9. This is going to be 16, or 4 squared, so my b value is equal to 4. Okay, so what does that mean then? Well, this really represents the x and y axis radius, just like what we did with ellipses. Now, it's essentially the same thing. Really, there's very little difference in what I'm doing for my hyperbolas compared to my ellipses. I still want to find my y-x-axis radius, 3, 4, 5, 6, 7, 8, 9. Okay, I still want to find that x-axis radius. Okay, I think I better compress that a little bit. Okay, so trans x. So I'm going to go 9 along the x-axis. Shorten that up a bit. Okay, so that represents 9, 0. I'm going to go the same distance. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's about the same. Okay, so that's going to be negative 9, 0. I need to do the same along the y because there's a vertical expansion of 4 along the y. So 1, 2, 3, 4. Okay, so that's going to be 4, 0, and then 1, 2, 3, 4. So that point's going to be negative 4, 0. So really it's the same thing. Now if I was doing an ellipse, I would just sketch in my ellipse. Okay, but the difference now is this compression along the expansion along the y gives me my rise. The expansion along the x gives me my run. Essentially, these are going to give me slopes. To be able to draw these slopes in, it's really useful and handy to have my rectangle. Okay, so instead of drawing an ellipse with those dimensions, I'm going to draw a rectangle with those dimensions. Okay, so I'm going to just highlight that with the little dotted lines. And why am I drawing in a rectangle? Well, it allows me to get, really what's important are these corners. I don't really need the rectangle. I really need these corners, because these corners indicate how much my slopes have been compressed and expanded. It allows me to then draw my asymptotes. Okay, so it allows me to draw asymptotes through there like that. And that will affect the shape of my hyperbola. Now, since it's trans x, I'm not going to draw up here. I'm going to draw along the x. Okay? But if it was trans y, let's say I just change that to minus, all it would do is change, it wouldn't change all this setup. It would just change my final picture of where, if I'm going to draw along the y-axis versus drawing along the x-axis. Now, since it's trans x, I just draw my hyperbola. Again, the only things I need for my hyperbola are my vertex and my asymptotes. If I have the vertex and asymptotes, I just start at the vertex and follow the asymptotes, and that's how I get the graph of my hyperbola. So there it is. Now, it's really important to make the connection here. This is very similar to an ellipse, what we did with ellipses. It's almost exactly the same. The difference was here we finished this off by drawing the ellipse. Here we use those same points to help us locate the expansion and compression of the asymptotes. It allows us to build this rectangle to get the rise and run slopes of that new hyperbola. So if the vertex is along the x-axis, we're going to just go plus a plus minus a. If it's along the y-axis, same thing. We go plus b minus b. So regardless of whether it's a trans x or y, we set it up exactly the same. The difference then would be whether I draw it through here or whether I draw it trans x. And what's really important to recognize is, notice that the asymptotes are going to be the rise and run, the y-axis expansion, the rise, the x-axis expansion is my run. And you can see that here, right? There's my run, there's my rise. Okay? There's my run, there's my rise. That's the right slope. There's my run, there's my rise. Okay? You can see that those are the slopes that we should get by those expansion and compression amounts.